Um, and
Sorry.
certainly, oh, that's great. That's great. And certainly parts of the Caribbean very, very intensely vulnerable to parts of climate change. So to aspects of climate change. So mostly what we'll be talking about here is how farming can minimize the effects of climate change by drawing down extra carbon dioxide from the atmosphere. But we'll talk a little bit about how it can help you adapt as well. It's not going to do anything. It's not going to resist 140-mile-an-hour winds and 20-foot deep flooding. But there is a lot of benefit of living in the new kind of chaotic climate that is the context that we're working in. Um, so we'll talk about some of those things. Climate change is bad, right? Yeah, it's bad now, and it's projected to get a whole lot worse um, by the end of the century. And the way I like to think about climate change, I learned this from John Foley over Project Drawdown, is that we can think about climate change as being like a faucet that is overflowing. So if your sink is overflowing, the sink itself is the atmosphere, right? So the water coming in out of the faucet is the emissions, is the greenhouse gas emissions. So the first thing you do when your sink is overflowing is you turn off the faucet. That's shutting down the emissions. The second thing you do is you mop up the water all over the floor. That's removing that extra carbon and capturing it in soils, capturing it in trees, and so on. You don't start mopping and just leave the faucet running. That doesn't make any sense because you're going to be mopping forever. But you also don't turn off the faucet and leave the water all over the floor. You got to do both things. So mostly tonight we'll be talking about mopping up the mess. Um, and it's worth noticing that agriculture isn't only affected by climate change, but it's really a big part of the problem. If you combine clearing of land for agriculture, like cutting down forests and stuff for farming, emissions from farming itself, emissions in the supply chain, like refrigeration and transportation and processing of food, and then the waste at the end of life of like food waste that ends up in the landfill and stuff. It's about a third of all of humanity's greenhouse gas emissions are coming from the food system. So it's a really big part of the problem. But also it has a tremendous potential as part of the solution, and actually has a bigger chance to be part of the solution than like say transportation or electricity generation or buildings and cities or any other sector of civilization, because unlike those, we have the opportunity not only to reduce our emissions but also to capture and store carbon, um, which none of those other sectors can do. So that's kind of cool. And just very briefly, overall, a whole food system, what can we do? How do we do it? The first thing is to reduce the waste of food. The world is still wasting somewhere between 30 and 40% of all the food that we grow. So all the emissions that are part of growing that food are basically wasted. It doesn't even end up feeding anybody. Um, in wealthy countries and among wealthy people in any country, changing diets to foods that have less emissions and use less land is really important. Meat would be a big example of that, but not the only example of that, to have less meat in people's diets. Um, in countries like the United States, to grow more food on the land we have, to intensify production. If we can increase the productivity of the farmland we have, then that can help to reduce pressure, cutting down forests, and cutting down forests is a big piece of emissions. We can cut back on the emissions from farming. Um, if you are raising cows or goats or sheep, um, and you feed them the leaves of different kinds of trees, like in the Virgin Islands, that might be Lucina or mulberry, um, um, as a few examples, or in Vermont, that might be again mulberry or willows. You can reduce the methane that comes out of those cows. Sequestering carbon, which we'll talk about, that's the drawing down extra carbon and storing it. And then some changes in the supply chain. Can we shift to different refrigerants? Can we move from gasoline trucks to electric trucks? Can we change the way processing is done to reduce emissions from that? So this is kind of like the big picture of the food system overall, but we're really just going to be talking here pretty much today about sequestering carbon. And what this is really about is, plants breathe, right? They breathe in carbon dioxide, and through photosynthesis, where they take the sun's energy, they can take those molecules of carbon dioxide, they break the carbon and oxygen apart, they let the oxygen go. That's what we breathe. That's really great. And then the carbon they make all kinds of cool stuff about with some of it ends up in the soil as organic matter or humus, the stuff we really need in order to be able to grow food. Some of it stays in the living tissues of perennial plants, like in the roots and trunks and branches of trees. And some of it ends up in long-lived products from the farm, like wool or wood or bio-based plastics or anything like that, bamboo products. So this is a really, really, really critically important tool. And one thing to know about it is that the more trees in a system, it varies. Carbon sequestration varies between different practices, between different climates, but the more trees there are, the more carbon there's going to be. In the Virgin Islands, you're going to see more in the more of the carbon's going to be held above ground in the biomass of trees. In Vermont, more of it's going to be held in the soil as opposed to in the biomass. In drier places, like on the dry sides of some of your islands, there's going to be less. On the rainy sides of some of your islands, there's going to be more. So it varies a lot from place to place. Jesse, this is those hickories at Badger Set from like 10 years ago, once you were just visiting. Yeah, let's see. Okay, so we're talking about systems with trees, systems that grab us extra carbon dioxide out of the atmosphere, which is what is the primary cause of climate change, and they catch it and do something useful with it. They sort of turn it from a pollutant in the atmosphere into something useful that helps us to farm better, to farm more sustainably, to feed ourselves, to restore degraded land, and has all these other benefits. So how does it help us survive a crazy climate change? Well, trees keep things calm around them. So when it's hot, they make it shadier. When it's rainy, they can make that rain come a little gentler under them sometimes. They can keep the grasses growing under them tender and better to eat for livestock for longer. They certainly make animals a lot less stressed. And for people working in a field on a hot day, they can make a big difference. The shade can make a big difference as well. They give us better pest control. And one of the things we're looking at with climate change is shifts in the kinds of pests and diseases that go after agricultural crops. If there is enough of the right kinds of perennials, trees and other perennials in enough parts of a landscape, they can have a role in reducing flooding. Agroforestry and perennial crops can help us to diversify our farms, to grow more things. And one of the things that's been found after hurricanes, for example, is if you have a mix of crops, you're more likely to bounce back faster than if you were only growing one thing. You're sort of hedging your bets by having different kinds of crops. For long dry periods, having more soil organic matter really helps increase the storage of water in the soil. And extreme weather, intense rainfall makes erosion way worse. It makes you lose way more of your soil through runoff and way more of your nutrients through runoff. So the kind of agroforestry systems and perennial crops we'll be talking about tonight really help with that, to reduce that kind of erosion. And then some of these deep-rooted perennials resist drought better as well. So there's lots more that can be said about that. But that's a start. And then there's all these other cool benefits of these long-lived perennial plants like trees. There's less need or no need to turn over the soil, which is less work and less erosion and less loss of carbon. Can have better habitat for wildlife. You have much better use of water and nutrients. Most annual crops may use like 50% of the nutrients and water that they are provided with, and the rest kind of washes away. So having some trees in the mix really helps to catch and um, use those nutrients. You can often get a longer season of food earlier or later into the season, which is great. And in many cases, they can grow in places where we can't grow annuals, places that are too steep or too wet or too shady to grow annual crops. We can find things that can grow there. So that's just like the 5-minute version of carbon farming and why. And I just should say that when it comes to reducing emissions, it's different. But as far as sequestering carbon, as far as drawing down that extra carbon out of the atmosphere and storing it in the soil, storing it in the living tissues of these perennial plants, none of those practices were invented because of climate change. They were invented because they're a good idea. Some of them go back thousands of years around the world, particularly in the tropics, but also in colder places as well. Also in Europe, also in North America, go back a long, long way. And they were developed because they're a good idea for the farm. They're a good idea for what's downstream or nearby the farm. And they're a good idea for the farmer. It happens that they do something good for climate change, which is great. Um, um, but it's not like we're trying to get people to do something strange that gives them more hardship in order to solve a problem like climate change. It's actually something that is already a good idea that just has these extra benefits and gets more attention, I think, and gets more funding as a result of that as well. So let's talk a little bit about agroforestry systems. Agroforestry is when you combine trees with annual crops, or you combine trees with other perennial crops, or you combine trees with livestock production. When the trees themselves might be a crop, or they might really be there to support the other crops or livestock. And again, some agroforestry systems go back as much as 10,000 years in parts of the world. So these are ancient practices, but there are also a lot of new refinements and developments to make it work better in our current context. So let's talk a little bit about those. So the first is there's all kinds of agroforestry where you have kind of strips of trees around the edges of the farm. They might be windbreaks to improve productivity and reduce erosion. They might be living fences to keep livestock out, or living fence posts to save money. Just put I'm sure that in many of the Virgin Islands, there's cutting of branches of things like quickstick or whatever you want to call it there, Gliricidia. You stab the trunk in the ground and it sprouts and grows a new plant, and you can use that as the basis for tying up your barbed wire and things like that. Those are living fences. And then riparian buffers are growing along like streams or the edges of rivers or other bodies of water, and they sort of help to make a buffer between the farming part and the water part to keep nutrients and pesticides and sediment from running into the water and poisoning the water and killing fish and stuff like that. And they also the trees in them cool the water and make it a much better habitat for organisms in the water, again, including some of the fish we like to eat. So this is kind of a set of agroforestry systems that work around the edges of the farm or the edges of a field to start. And another example, this is starting to get into the field, is strips of trees or shrubs planted very closely together right along the contour of a slope for erosion control, or maybe slightly off the contour for erosion control. So if you want to be plowing land on steep hills, it tends to erode really fast and degrade the quality of the soil really fast. So these kinds of strips along the slope can really help to reduce that erosion, and actually over time they can sort of make living terraces. And you do see this a lot in different parts of the world. This particular one is in Mexico. But this is a great technique. Here in the US, you'll see this with just strips of perennial grasses. That works fine too. The trees give you a little extra edge with it for sure, but it works okay with perennial grasses too. Trees, grasses, and shrubs together even better. Then those trees can be in the field and mostly focused on fertility, on fertilizing soil, on improving soil. Really, for this, we're using trees that fix nitrogen, that take, this is another example of plants taking something out of the atmosphere and turning it into something useful. In this case, they're taking nitrogen out of the atmosphere and turning it into fertilizer, to nitrogen fertilizer, by working with some microbes that live in their roots, in or on their roots. You see this a lot in tropical agroforestry and almost not at all in agroforestry here in the US, which I think is a big mistake. That's partly because we have so much use of heavy duty synthetic fertilizers here that we don't need to worry about that so much. But I'm certainly doing it here on my farm. So on the left, that's a shot of my backyard, my backfield, where we have nut trees. But in between every nut tree are a couple of nitrogen fixing shrubs that are there to help add more nitrogen to my extremely infertile, very degraded, very sandy field, to help support the growth of those nut trees. And actually, it's especially important for nut trees because nuts have a high level of protein. Many nuts have a high level of protein, and protein is full of nitrogen. So you need a lot of nitrogen to be able to grow protein. The one on the right there is a system, and I should say there's like hundreds or maybe thousands of variations of all of these kind of systems I'll be talking about. This one here I really love on the right. That is called evergreen agriculture. This is a tree called Fiderbia albida, mostly grown in the semi-arid regions of Africa where it's native. This is a nitrogen fixing tree. It's related to all the kinds of acacias and lucina and stuff that you see through the Caribbean. But what's really unique about it, this is a part of the world that has a strong rainy season and then a strong dry season. This tree puts out its leaves in the dry season when there's no crops growing underneath it and fixes nitrogen. And then when the rainy season comes, it drops its leaves to the ground where they make a nice nitrogen-rich mulch. But it's not casting shade on the crops during the season when you're growing the crops. You're able to have a very high density of those trees. You can see this is almost like an orchard kind of spacing here, but they're not interfering with growing the crops because they're growing at a different season. And that's one of the things we see in agroforestry is can we line things up so that the plants are in the same place, but they're not growing actively at the same time. So they're not competing with each other during the days that they're growing actively. And there are many other systems like this with nitrogen fixing plants being grown for fertility right in the middle of the field, right in the middle of the crop field. And then sometimes the trees are crops also. So you would have your annual crops or other perennial crops going in between. And then in the upper photo, those are mostly hazelnuts. That's in England, where this kind of thing is a little bit farther along than it is here in the US. In this case, this farm mostly grows like potatoes and oats in with the hazelnuts. And in the bottom, that's my friend Roberto's farm in Guatemala, where we have avocados, and African perennial basil, and some forage grasses and forage mulberries that are cut and fed to his cows. And then in between, he's growing squash this year, but in different years, he grows different crops. So this is a combination of the crop being, the trees being a crop, and the space in between being used to grow crops. The disadvantage here is if you don't have enough nitrogen fixation, you have to bring in your fertility. That's something that can be worked out, or you might grow cover crops every so often in those annual cropping areas, or you might have nitrogen fixing plants mixed in with your productive crop trees there as well. But so this is something we do see in lots of different climates. This is in the highlands in Guatemala, but you see this also there in the lowlands as well. So then we have just perennial versions of all kinds of crops. One of my favorites is trees with edible leaves. This image I used in a book that I wrote recently on trees with edible leaves, which is a free download if you want online. And just about every part of the world except Vermont has domesticated or brought into cultivation some trees with edible leaves. They tend to be, and sassafras, which grows in Vermont, is sort of the closest one we have, native one we have here. That they are exceptionally nutritious as a group. A few of them aren't so good, but mostly they're extremely nutritious. They're very easy to grow. Usually we don't actually climb up into them like that. We cut them down about 4 feet high once or twice a year and allow them to resprout. That tender growth stays tender for a much longer time that way. It's easier to harvest. And you see that a lot with moringa. This is a different species in moringa in this photo. This is African moringa. But there's lots of species that do really well in the Caribbean, including a lot that are already widespread in the Caribbean. And then there are quite a few species we have to work with here in the northeastern US as well. But we have perennial fruits, we have perennial nuts, we have perennial industrial crops for materials and chemicals and energy. We have perennial cut flower crops for a high value sale. We have almost every kind of crop we like. We have a perennial version, except for roots. It's very hard to do that. And we're working on getting perennial versions of some of the grains and other annual staple crops. We'll talk about a few of those in a little bit. So as much as we can lean more perennial in our gardens, in our landscapes, in our farms, the more we get those benefits we were talking about in terms of fighting climate change, surviving climate change, and all the other goodies that come along with it. So another system, one of my favorite systems, I've sort of spent my adult life working on this, is what we call multi-strata agroforestry, meaning different layers together. So an example you see a lot in the tropics would be coffee or cacao growing in the shade of other trees. Sometimes those trees are wild native trees. Sometimes they're planted nitrogen fixing trees. On the bottom left is another one from Guatemala, where I've spent a lot of time with my wife's family, where this is in a church, like a former parking lot at a church, where you have mangoes and papayas and avocados and calabash trees. And underneath them, there's a layer of a shrub with edible leaves that also fixes nitrogen. That one's called chipilín. And then under that, you have like lemongrass, and you have sweet potatoes and hot peppers and all kinds of other great stuff, all irrigated with the roof water from the church. So that would be sort of a more intensive version. In the middle there is one from New York, where there's sugar maple trees for making maple syrup, and underneath they're growing mushrooms and medicinal herbs and raising ducks. And all the way on the right, there is one from Quebec, where you have hazelnuts and oaks that have been inoculated with truffle fungus, intercropped with different kinds of annuals. I think they've done like pumpkins and all kinds of things up there. So I would say that the tropics is about you know, has a several century head start on cold climates on this kind of farming. Not that there aren't traditions of doing it here, but those have been um lost is the wrong word, but mostly lost would probably be pretty fair to say. Um, and a particular, these are more like production systems, but there are also these home versions of the same thing, um, which sometimes goes by food forest in parts of the world, or we call the tropical home garden in some places. I mean, most of the backyards I've visited throughout Latin America and the Caribbean have all kinds of crazy fruit trees. My mother-in-law's has cherry and avocado and chayote and banana and papaya, and she has a little tilapia pond, and all in like a tiny, tiny little urban backyard. That's a really common practice in many places, which is absolutely fantastic. That's been taken off here in the US in the last bunch of decades. There's some pretty good evidence that that was how things were done here before Europeans came. Um, that some gardens looked a lot like that, some ecosystems looked a lot like that, and there are some indigenous people here still going strong with that, but really it's not a wide practice here. But that photo is from my old garden there, where you can see it's really started to fill in very nicely and started to make quite a young forest kind of atmosphere. And you do see those kind of gardens in Vermont quite a bit, and some people starting to figure out what it looks like to scale that up to a more commercial model. Then we have silvopasture systems where you have trees in the field with the animals. In the case of this particular photo, these are nitrogen fixing trees, but they're really just there to provide shade and fertility for the livestock, um, with some occasionally harvested for firewood. Then, so the trees might just be there to be trees, which is great, or they might be there in this case to feed the livestock themselves. So on the left, that's cows eating lucina, which is a really great food for them. Another nitrogen fixing shrub, very fast growing, I'm sure all over every one of the Virgin Islands. It's just super widespread throughout the Caribbean. It's maybe native, maybe not, but certainly native in Central America and has moved up and through. Um, so they might be eating the leaves, or they might be eating the fruits or pods. The other photo there is honey locust. That's a very blurry photo somehow, but where the pods are eaten by livestock, or above is West Indian elm, which is really, really fantastic. Both the leaves and the fruits of that are really great for livestock. And some of you have probably seen that tree around a lot, or some of you probably have grown that and use it to feed your animals. And then we have intensive silvopasture, which is sort of started in Latin America, moved to Australia, was refined, came back to Colombia, refined again, now spreading throughout lots of Latin America. It's big in Panama, Costa Rica, Nicaragua, Colombia. It's spreading into Brazil. It's spread into Mexico. I imagine there's people doing it through the Caribbean as well, where you have those lucina trees very, very, very closely planted to each other, like 2 or 3 feet apart, with grown with these intense pasture grasses, and you rotate the animals through. They browse it all down, and then you move them on to another paddock, and the stuff grows back, and you bring them in again. They found in Colombia that this increases the yield of meat or milk um, by 2 to 10 times. So it's incredibly more productive. It has a great impact on reducing emissions from those animals of both nitrous oxide and methane. Um, it sequesters carbon better than any other way we have to raise cows. I really think this is the absolute highest and best way to make um, beef or lamb or goat or dairy. In terms of climate, it's the very best way of any system we have in the whole world. So um, I think I love it. I love it. Was there a question there before we go on? No?
Just want to make sure that this is Tantan.
Yeah, it is.
Okay.
Not this one, the last.
Yeah.
Oh, no. Listen.
Are you hearing it or no?
Here?
Oh, that's not.
Yeah,
And it's like the other.
I'm not sure. Eric, are you hearing the discussion?
Tom, is that the name there of this tree?
Tan.
But what's the tree in the next slide?
Next slide, the Tantan.
Is that the same museum thing?
There's grasses in the front, like the Tom.
That's the same one. Same one
Yeah.
here that was on the left in there. Yep. Yep. Little white puffball flowers, big brown pods.
Yeah.
Grows like a terrible weed along the side of the road.
I wanted to give my house out. Sounds like that one. I'm big up. Bring it up then, let's see, yeah.
So yeah, I think it's interesting because I have no idea about cows and their biology, but I know that my when she would eat
Oh yeah, don't
sunflower
feed the horses. Yep. Yep. Makes all
oil,
the hair.
get back. And so like it has a negative effect on them, but like apparently cows have no problem with it. I'm like,
Yeah.
I'm interested to learn about that.
Yeah, it can even kill a horse. I've seen it make all the hair fall off of horses before. It's really sad. But cows have a fancier digestive system and they do just fine with it. Yeah, they shouldn't eat only it, but they can eat something like a third of their diet, that tree. So that with grass is just perfect for them. Yeah, great question. Great question. All right. Okay. We'll have lots of time for questions and stuff at the end too. Interestingly, cows in Australia, which didn't grow up around that tree, can't digest it. So they take bacteria from the stomachs of cows in Latin America and they bring it to Australia and they grow it out and then they inoculate the cows with it into their rumen and then they can digest it.
It has to be a better way.
It's crazy. It's crazy. Yeah, so some of it is just cows are better able, but also the cows in the Caribbean and in Latin America have had hundreds of years to get used to it. So they've learned to process the mimicine, I think is what it's called, the toxic stuff in there. So, okay, let's talk about stuff people can eat directly, although you can feed all these to livestock too. Perennial stable crops. So what's a perennial crop? I should have moved this one up to the beginning. These are crops that live from 3,000 to 3,000 years, something that's going to live for a good long time. We got trees and shrubs, cacti and other succulents like agaves, palms and bamboos, vines, grasses, herbaceous plants, aquatic perennials. There's others that can be in here, like certain kinds of mangroves and stuff. They have a mangrove in Southeast Asia that has a fruit that's supposed to taste like cheese. I'd really like to try that sometime. That sounds pretty cool. So there's a whole range of these kind of perennial crops, and many of you know and love them already. So we're going to walk through the ones that can provide staple crops. And when I say that, what I mean is they're high in protein, they're high in fat or oil, or they're high in starch. So this would be things like kind of the rice or beans or yams or potatoes of the perennial crop world. The first group is the ones that make basic starch. These are foods that we know and love, like taro, sweet potato, cassava, banana, plantain, that are mostly starchy. They have vitamins and they have fiber in them and stuff, but they're very low in protein and fat. They just bring you the starch. So some examples, tropical examples, breadfruit, which I'm sure is already all over there, and bananas and plantains. There's a number of others, but we're just walking through a little introductory piece here on these. By the way, the leaves of breadfruit are really good eating as well. The tender young leaves are very nice. And then in Vermont, we'd be looking at crops like chestnut and the yamberry, which is related to the tropical yams, but it makes these little tiny tubers in the air that taste like new potatoes. They're delicious. We have balanced carbohydrates. This would be things like rice or wheat that have some protein and some fat or oil. Potatoes are in this group. Corn is in this group. So this is your real like daily, your daily bread kind of staple. So some things worth trying in the Virgin Islands would be Maya bread nut, and there is a Maya bread nut foundation, or maybe it's called the Maya Nut Foundation, that's helping to finance people establishing plantings of that. Very nice eating. The nuts, also people make like a coffee from it, and the leaves are phenomenal for livestock. There is now perennial rice that will fruit well, that will produce as well as regular rice for at least 3 or 4 years and on into the 5th year. So that's very exciting to have a rice that doesn't need to be replanted every year, but it's just a big, thick clump. Peach palm. I wasn't able to find common names
What's this?
from the Virgin Islands for most of these. I have good names for a lot of Caribbean countries. But peach palm is it's a large orange fruited palm that you cook and eat, kind of like sweet potato. It's high in beta carotene. It's really delicious. People also grow it for the shoots. And then mesquite, which is arguably native. People have different opinions on whether it's native in the Virgin Islands, but Fixus nitrogen has these delicious pods that you can grind up or you can just eat raw. They're sweet and good, and they make great food for livestock as well. So certainly present there. In Vermont, we have less good options in a lot of these categories, but we do have mulberry. The dried fruit of mulberry is a balanced carbohydrate crop because the seeds bring more protein and the fruit has the carbs. The honey locust, very much a new crop or a returning crop here. That Jesse and other folks have been doing phenomenal work collecting the best varieties and getting the seeds and grafted trees of those out to people. And Kernza is kind of, we don't have perennial rice here, but the farthest we've come with having a perennial version of like wheat is this crop Kernza, which is a grass and it grows just fine here. It's not super productive. It tastes fine. But it's sort of like the first out of the gate of these perennial grains that we're more and more of them will be coming along. It won't be too long until we have perennial sorghum. There's work on perennial wheat. There's work on perennial rye. There's work on perennial sunflowers or sunflower relatives. There's some work on perennial beans. So we're getting there, but it's still we're still early. And the perennial rice work started in the 1970s, so they're way ahead of us. We're all waiting on perennial corn too, but that's going to be decades. And we have the perennial, basically your bean analogs. What's high in protein but doesn't have a lot of starch or fat? It's beans. Most of our beans are in that group. For the Caribbean, lots of people grow pigeon peas already, and they will live for multiple years, but they tend to yield really well the first year to make a lot of beans the first year, and then not so much after that. But there are varieties in India that will produce very heavily for many years. So that feels like a priority to me. And maybe there's some already around like that, that people are growing that I don't know about. And then among the many other perennial beans, for the Caribbean, maybe the best of them are the perennial lima beans. This variety is called 7-year because it will produce for 7 years, which is pretty great. That's really phenomenal. Some people will also, you can eat not only the dry bean, but the unripe beans and the pods and the leaves and stuff on there too. So it's a really great multi-purpose food plant. That both of these are nitrogen fixing plants as well. By the way, our best bet for a perennial pigeon pea analog for Vermont is probably the Siberian pea shrub, which needs a lot of work because it's kind of poisonous still. But I think that's the one that, with some breeding work, could be our pigeon pea someday. Meanwhile, what we have, which is still barely grown, is we have a native perennial true bean, the thicket bean, which is perfectly good eating. It's not really properly domesticated, but there are some varieties that show some evidence of that having been done in the past. And I quite like them. I grow them here. But certainly not ready to replace, black beans in our daily diet or anything. There's also this really cool thing for any part of the world, leaf protein concentrate. This is like a tofu or a cheese that you can make from leaves, the leaves of grasses, the leaves of certain kinds of trees, the leaves of like alfalfa, clover, nettles, not lucina, cowpea greens. You can make it from cowpea greens. Basically you make juice from it, and that takes the fiber out, and then you just simmer it. You bring it to a boil for like 30 seconds and the protein coagulates out. You run that through a cheesecloth and you get this intense green stuff, which tastes very strong, like wheatgrass juice, but is insanely nutritious and super high in protein. At the very least, great to feed to like pigs and chickens. But I find if you mix it in with like avocado or in with hummus, it tastes great. So this is kind of like the ultimate vegan, climate friendly protein.
We don't eat it. We have something like that. We don't eat it. Chlorophyll, basically. We just basically blend down different types of grasses and different types of moringa thing, and then we just drink it after we strain it. But yeah, that's interesting. Eating grass.
And nothing makes more protein per acre or per hectare than leaf protein concentrate. It makes more than soybeans. It makes way, way, way more than any kind of livestock we can grow. It does not taste as good. It probably tastes a lot like your, moringa leaf kind of stuff. It's pretty strong, but you mix it with things and it tastes great. It tastes good that way. Moringa, phenomenal, by the way. Phenomenal plant, really great. And some of our trees with edible leaves that grow here are every bit as nutritious as moringa. We just don't grow them as much. So we got to step up our game on that. All right. Oh yeah. No, another question?
I was just saying, like what? I just said tune and mulberry.
Tune and mulberry would be are the two of those. Yeah, the edible leaf goji is probably in that category as well. Castor Aurelia, the 5-leaf Aurelias. Yeah.
Eric, before we jump past the protein, I just wanted to ask a question. You had mulberry on the complex carbohydrate. Given that at least in some studies they can be like up to 25 or +% protein, I know they're not a bean, but couldn't they still be considered as part of a heavy protein crop, or is that not a place?
It could be. Yep, they could be. I'm sorry, do you mean the leaves or the fruits?
The fruit.
The fruits?
I mean,
yeah, they would.
As well, but I've seen some studies say up to 28% protein of the fruits when pollinated.
Yeah, that would definitely fit that category. Yep. And there are some other things as well. African bread nut would be in there too. It's not only beans, it's just mostly beans. Yeah. Well, that's great. And again, maybe you're feeding that to pigs and that's okay too, right? We're not talking about only making people eat these things, but there's certainly no reason to feed corn and soybeans, perfectly good annual crops we could feed to people, to livestock, when we could feed them something that comes from something perennial and has better benefits. It feels to me like if we're going to disturb the soil and grow annual crops, it should be only where it's really appropriate to do that. And it should be to do things that are the highest and best use of that food, which is to feed people. Okay, we have crops that are high in protein and oil, like soybeans, peanuts, cashews, sunflowers, pistachios. This is a great group, a really delicious group. And both the Virgin Islands and Vermont have some great candidates here. Just some fun ones. The cashew, of course, is a great one there. And ackee, which if it's not ripe, it can kill you, or if you eat the wrong part, it can kill you. But it has as much protein and fat as a cheeseburger.
Oh.
And that's
Wow.
pretty cool. Yeah, people call it vegetable brains sometimes because it's kind of like scrambling up brains. Um, is that a thing people eat in the U.S. Virgin Islands? You see it in some other parts of the Caribbean.
Aki? Yeah, all over the Caribbean. Yeah, Aki, Kaki, all them.
Oh, yeah. Yeah, that's a great example of a protein and oil fruit. And then winged beans, which are a really interesting kind of like semi-perennial bean where you can eat the dry bean, the green bean, the pod, the leaves, the flowers, and the tubers. It's a really incredible um, multi-purpose plant. And there's lots of other things, of course, but I just thought I would try these two. I know cashew and ackee were probably all over there, and the wing bean, I don't know about, but it's definitely a really nice one. In Vermont, in this category, we have all different kinds of walnuts, some different kinds of hazelnuts, some different kinds of hickories, among other nuts that are in this category. So this is a really good, strong category for Vermont. And again, there are lots more I could put in each of these. I'm trying not to bore you all to death after you had a very long day already today. And then some crops that are grown for the oil, whether that's just to press the oil or like olives, maybe you're pressing oil, but also eating it. Also eating like the fruit or whatever itself. So we have coconuts, we have avocados, we have the African oil palm, so many kinds of palms pressed and used for their oil, and lots of good oily fruits in the tropics as well. Certainly the avocado might be the reigning king or queen of those. Yeah, and if you haven't had avocado oil, it's pretty fantastic and nutritionally very, very similar to olive oil. It's a really, really good quality oil. And oil palm gets a very bad rap with a lot of people because when it's chemically processed and hydrogenated, it becomes, all kinds of bad for you. But raw oil, oh, that says oil palm, doesn't it? Hang on, let me fix that. There we go, oil palm. But raw palm oil is amazing. It's red. It's incredibly full of vitamin A. It's actually one of the highest levels of vitamin A of any food on the planet. And I quite like working with it. And even though oil palm is grown in these terrible plantations a lot of the time that are causing massive deforestation around the world, that's not oil palm's fault. Oil palm can be grown in polyculture systems and grown in agroforestry systems. It's a perfectly lovely plant that produces really well that is mostly grown in a really horrible way, but that's not its fault. Also, we're starting to see avocados and coconuts grown in more and more horrible ways. That's not their fault either. So some species for Vermont, we have sea berry, which is, if you imagine like the flavor of a passion fruit, but really high in oil. Pretty fantastic. Also fixes nitrogen, which is great. The leaves are great for livestock. And the yellowbud hickory, you have maybe the world's greatest or part of the team of the world's greatest crop champions for yellowbud hickory right there in the room with Jesse. And I think y'all are going to be harvesting some of these really soon. Something that has an ancient tradition of use in this part of the world going back, maybe 10,000 years or something. We have great archaeological evidence of hickories being used here as the most important food plant in the eastern United States for a really long time, for thousands of years. But until very recently, yellowbud hickory was not getting a lot of use around here. So it's really great that Jesse and Eric and others have been working so hard and collaborating with Jennifer to get this back in people's diets. The oil is really delicious. It's very good. Some places to go if you want to learn more. These are a couple projects I've been involved in. On the left is the Drawdown website that has a bunch of these climate solutions, and you can read more about them. I wrote a thing for them as well called Farming Our Way Out of the Climate Crisis. This kind of goes through an overview of the emissions from agriculture and the emissions reduction potential and the carbon sequestration potential. And then my book, The Carbon Farming Solution, which goes into lots of detail and has many, many, many chapters on perennial crops for all of the world's farmable climates. And the last thing I'll say before our question and answer is happy birthday to Avia and Kirsten. So, all right, let's, we can, oh, there we go. Great.
Any questions for Eric? All right, you want to say it loud?
So you were talking about how corn is a perennial. Can you go more on to that? Because I only know it as an annual.
Corn. Yeah. Yeah, corn has some perennial relatives, and there have been people working to try and cross it with those perennial relatives for many decades. It looks feasible, but somebody just has to throw a bunch of money and time at it to make it work. It would be pretty amazing if you could have corn that would come back every single year, and not need to be replanted. It would really make a huge difference for erosion control and stuff. But it's going to be a while. That one's going to be a while. It's not an easy. Some of them are kind of like perennial rice was easy because there are wild forms of rice that are perennial. So you're just crossing the same species with itself. That's not too hard to do. That's very conventional plant breeding. With corn, it's not like it's genetic engineering, but you have to use some more tricks to try and get it to cross with some more distantly related grasses to get them to try and make offspring. And then you end up with these really tiny ears of corn that aren't any good to anybody. So it's a long-term project. It's more like a, for the next generation kind of project.
So when you're doing like, when you're planting annual crops or something in alleys with rows of trees, how do you balance like the sunlight distribution? Because I imagine as those trees get bigger, they might shade out a lot of potential crops underneath them.
Yeah, I'm doing a whole book on this. The one guideline is if you figure out how tall the trees are going to be when they grow up, when they're like mature, then you want the distance between the rows of trees to be 2 to 3 times the mature height of those trees. So if they're going to be 100 feet high, you want those rows to be 200 to 300 feet apart.
For a static system.
That lets, yeah, if you want to always be able to grow annual crops in between, you can have them be closer together and just shift to something that can handle more shade after 20 years or something. That's fine too. Or harvest the trees, you know, for timber. And some of the crops that grow in the alley are more shade tolerant than others are. Corn is one of the worst. It only wants full sun, same as like tomatoes and squashes and stuff. But wheat and oats and potatoes and leaf vegetables like cabbages and kale and stuff are happy with some shade, and some things like garlic and asparagus can take really almost a shocking amount of shade without really much trouble for their yields. And then the trees themselves, a deciduous one is better than an evergreen because it's not casting shade all year at least. Some trees have more open, some trees let more light in than others. Honey locust being one of the very best for letting in more light. Some trees have deeper roots. It's better to pair deeper roots with the annual crop. So there's like a lot of different ways to try and make it work. And the one tree we have that is kind of perfect for mixing with crops is honey locust. And the next best are the walnuts. Even though they give off some herbicide that slows down some of the annual crops, they have an open canopy and they don't leaf out until really late, and they drop their leaves early and they're deep rooted. So they have a lot of the characteristics. It's really about trying to understand the traits and characteristics of the trees and the crops and how best to match them up with each other. But the 2 to 3 times width, 2 to 3 times the height is a pretty good guideline to start with here. In the Virgin Islands, they can be a lot closer together because the sunlight is so much more intense. So it sort of depends where you live. Yeah, that's a good question. Anybody else?
So I was wondering, do you guys like vines and berries? I would think would be perfect to go with trees. They are okay with the shade, and those are a crop that you could, if a plant is gonna get too tall, I think you can put berries right underneath and you put vines onto it. That would then be able to continue to have a crop, even if it's, I was wondering about that, like how much have you thought about vines and berries in Vermont and in other parts of the world that are being used with tree systems to create the food forests that were often found across the world?
Yeah, I mean, I certainly have seen a lot of that in different places, and I've done it myself for a couple of decades. Sometimes the vines are too big and they strangle the tree, or you plant them when the tree is still too young. You have to like wait until the tree gets big enough to handle them. But yeah, that can work really well. Sometimes the fruit ends up being way too high up in the tree and it's hard to pick. So you want to kind of like think about matching the right vine with the right tree and the right pruning and stuff. And a lot of our berries do very well in some shade. Like the currants and gooseberries in particular do really well. Um, yes, they do very well. One of our or pawpaw, which is like our soursop, sort of like our soursop, like some shade as well. One of the challenges with some of our berries is they're really thorny. So if you're trying to get in and prune your trees, but you're stepping through all these really thorny shrubs, that can be literally painful. So, but yeah, I think there's a lot of potential with that. My personal experiences with that have been really good, and we definitely have commercial farms here doing that, as well. Very much similar to how like coffee and cacao are grown in the shade, and they're fruiting. We don't eat them as a fresh fruit, maybe. I mean, you can with cacao, but there are fruits that will grow pretty well in the shade in both places. And certainly there's some great vines for the Caribbean as well, that like chayote vines, or what do you say, choco, mirliton, chayote, the little, the green squash that,
Oh yeah.
Yeah, is that chayote?
How much of that? We don't eat that much of that right now. I think the vines that we use the most of are like passion fruit. And there's also some wild types of passion fruit that like that's the most that you'll see in people's yards, like going up between trees and things.
Yeah, that's great. That's good. We have a hardy passion fruit here too, not for Vermont, but it'll grow here in Massachusetts. And that's a really good one. Yeah, probably yams too. You probably grow a lot of yams up on trees.
Oh yeah, they do grow, they do like to go up trees, but yeah, that's right.
Yeah, those are great. We have a couple good yams that'll grow here too.
Leaves, and you can eat the leaves.
Eric, I'm curious, so grateful for all that you've shared in your work and research, and my mind is sort of fixated on your initial metaphor with faucet. And
Yeah.
I'm curious in your work and your travels and relationships and research, what cultural levers you see being utilized for the quick change. I mean, I know change isn't quick, but yeah, what's working and how are they making it work?
Well, on the one hand, some things are spreading so much faster than I would have ever thought possible. It's not fast enough to do what's needed, but it is faster than I would have ever imagined. So sometimes there's a bunch of, one lever is getting bad regulations out of the way. So like in Niger, where half of all the farmland in Niger is now in agroforestry systems, in a system that was developed there in Niger called Farmer Managed Natural Regeneration, every tree was the property of the government. And if you wanted to prune it, you had to get a permit. So nobody wanted any trees on their farm, because why would you want to have to go and get a permit to like cut a branch of firewood off of your tree? So when they got rid of that, that helped this practice really take off, and it is spreading very rapidly through East Africa. People are saying it's the biggest environmental transformation that's ever happened in Africa. It's really, really exciting, including with that Phyderbia tree that I was showing that has like the backwards leaf timing. That's one example. Another is if the people who are buying the food really want that, like we have seen with organic, like we've seen with grass-fed, where the consumers are helping to drive the process. Sometimes we have governments that insist and don't give people a choice. Like we've seen that in parts of China where the land was totally degraded and falling apart, and the government just said, you're now going to put in terraces and plant a bunch of trees. That's not the way I'd maybe like to see it done, but it certainly worked. Um, I think about Cuba, where it was really driven by with the collapse of the Soviet Union, and then the trade embargo led by the US, you end up with people who suddenly had no inputs anymore and had to figure out how to grow food on a big scale in order to feed themselves while they were having a food scarcity problem. And there was some intense, what I really understand to have happened there was a farmer driven and gardener, even like urban gardener driven push to get access to land and to grow stuff organically, which was then actively supported by government and universities, which seems like a pretty good model to me. Is people drive it and the government helps them. You don't see that a whole lot, but that's a really good one. We see some governments paying farmers to implement good practices, including sometimes here in the US. We see some grants helping people get the money to go up and running. Sometimes it's just that farmers are really excited about a practice, like the spread of holistic grazing in the US is partly because the consumers want to buy it, but also because the farmers are just so passionate about it. The ranchers are so passionate about it. Spread of cover crops in through Central America was mostly because of people really their land being so exhausted and really desperately needing something to restore their soil. So there's lots of different examples, and the things holding it back are different in different places. Sometimes it's people don't own their land and they don't have a good tenure on their land. And when you can make that happen, then they're able to put the changes in. But why would you plant a tree somewhere you don't know if you're going to be able to be farming there the next year? Sometimes it's access to a special piece of equipment that lets you do something much, much faster that makes it easier to do, like maybe some nut processing equipment. Sometimes it's access to particular kinds of seeds or other kinds of plant material or livestock breeds that's needed in order to make something happen. There's all different kinds of levers. I read an article recently that looked at practices that the U.S. Department of Agriculture funds that are best for soil health. And they evaluated all the practices that are in the EQIP program. And the agroforestry practices were at the very top of the very best, practices for making these kind of desirable changes by USDA's own numbers, and yet they're funding them with way less than 1% of the funds. So it's often a matter of shifting the money around. It's often mostly about the money. If you can shift the money around to help people establish these practices and wait long enough for them to start to work. The last one I'll mention is some kind of bigger food companies are paying their farmers to implement these practices because they can't get enough of stuff grown the way they want. So like Annie's Mac and Cheese has paid for, I don't know, 200,000 acres of wheat to go organic in North Dakota, things like that. They're paying the farmers to make a change so they can get the kind of ingredients they want. So it can come from the top, it can come from the farmers, it can, the money is key, but the education and information and the seeds and equipment, access to the land, those are all important pieces to making it happen. Yeah. And some of these practices are being done pretty widely, like cover crops are being done on something like 15% of all the world's cropland. That's really a lot. It's totally not enough, but it's amazing that it's that much too at the same time. agroforestry is being done on an awful lot of the world's cropland as well. Not enough, but a lot. It's spreading fast. Colombia is putting intensive silvopasture at the heart of their climate program, national climate program. That's a really big deal. And the climate thing actually is, I think, a big motivator for bringing interest and money to these kinds of perennial systems that wasn't there before. So, yeah. Anybody else?
I have a question. So pretty much the basic purpose of agroforestry is to slow down emissions or just to soil enrichment.
I think for any individual farmer or gardener, it's more about the soil enrichment.
Because of the nitrogen.
Yeah, they're getting nitrogen fixation, they're building their soil organic matter. I think that's the main real, and getting new crops, getting good crops out of it. But it helps the whole world a lot when they do that at the same time. But like, no farmer is going to solve climate change on their one farm. So that takes millions and millions of farmers to make the difference. But meanwhile, it helps their farm with nitrogen. It helps their farm with shade. It helps their farm with food for their livestock. It helps their farm with new crops, things like that. Makes it maybe hold up better during storms and things like that too.
All right.
How do you see this playing out on a really small scale, like on a micro farm? Trees are really big organisms and they are long-lived, and so people with just tiny amounts of land, you know, they want to use some of their land to cover crops, annual crops, and then the successions that are, you know, multiple times per year. So how do you see trees and other perennials, larger perennials fit into systems like that with high turnover, high succession rate, and not a lot of space?
Sure, I mean, berry bushes are great. Maybe it's just shrubs instead of trees. Or just a few trees and smaller trees. On my 1/10 of an acre backyard, it was 45 feet by 90 feet. I had 50 species of fruit and 70 species with edible leaves and all kinds of stuff. You can pack a lot into a very small place. But yeah, I mean, just go with smaller stuff, smaller shrubs and dwarf trees and stuff, and some of the woody vines and stuff are great for those kind of setups too.
Edible leaves seem like an important component of the small scale as well. Highly recommend this free resource on his website, has tropical and temperate species trees with edible leaves.
You mentioned the riparian zone. Would you consider like mangroves part of agroforestry at all?
Oh yeah, yeah, and there's lots of mangrove agroforestry systems around the world too, for sure. Yeah, yeah, some aquaculture systems where you're mixing the mangroves in with like some fish and shrimp and stuff. Some people manage it for firewood and all kinds of stuff, restoring mangroves. In a way, mangroves are already agroforestry because that's where the baby fish live that we eat later on, right? So it's like aquaforestry. Yeah, I think they're super important. And also, by the way, mangroves have something like 10 times more carbon in them per, you know, square foot or whatever than a regular forest. They're like incredible, phenomenal for carbon, and also, of course, really help to slow down the storms and stuff too. So yeah, big fan of those.
Thank you.
Yeah. Here we have salt marshes instead of mangroves. They're not nearly as cool, but they do the same thing as far as the fish is concerned. They do a good job.
So I have an acre of depleted soil, right? Like I test the soil is depleted. If I just plant a bunch of annuals and perennials in a type of system, like what, in a year it's gonna like replenish the soil? In a couple of years?
A general guideline I've heard from people is you can start to see a really big difference in like 1.5 to 2 years if you're doing it right. Yeah. And that's kind of been my experience, my very limited personal experience on this and that farm and garden where I worked and stuff. But that's the kind of number I hear a lot is you can start to see, I think you'll see it faster in the tropics than here because the trees are growing faster and stuff. And there's certainly, it continues to be a benefit for many decades to come, but you can start to see a pretty quick turnaround if you have a high density of those trees in there, especially the nitrogen fixing trees. Yeah.
I just wanted to ask, a lot of those images you showed, whether it was planting a crop low to the ground, or trees, they were placed in straight lines. As crops have been, planted for centuries now. Have there been, in your experience, or have you read about experimentation with kind of shaping it in other ways, in which it's more productive?
Sure. I mean, the main reason people do it in straight rows is so you can get a tractor through there. So in parts of the world where people plow with oxen instead of tractors, they're not in straight rows. They're anywhere because you can move the oxen wherever you want and it's no problem. And there's like in Greece and Italy, you see systems with like olive trees that are hundreds of years old that are just kind of to our eyes, to my eyes, just randomly planted in the field, but they're not randomly there. And I think the more irregular it gets, the more you get certain kinds of ecosystem benefits and habitat benefits and stuff. And even with the tractors, I mean, they might not be a straight row if it's along a hillside. It might be much closer to the contour or the key line of that slope. So you start to get some more interesting shapes that way too. It's mostly just about the straight lines are mostly just about bringing the tractors through. And certainly like here in New England, 500 years ago, they weren't in straight lines at all. The trees were just coming up through the field in what would appear to me a more random kind of system. I see that in Guatemala where in the vegetable fields, people are eating avocados for lunch and they throw the pit and an avocado tree grows. And so there's an avocado tree there and they're just kind of scattered here and there through the field like a park kind of a look. That's kind of agroforestry. It's called parkland agroforestry actually. And that works just fine if you're not trying to get through efficiently using a tractor. That's a great way to go. You get a lot of benefits that way, but it's sort of a compromise between the productivity on the one hand and efficiency, and then the ecological benefits on the other. And I think each farm has to decide for them what that looks like.
Any questions, y'all? We're right on time.
Question for them.
Okay.
Who wants, show of hands, who wants to make this shit happen in your communities? Study your resource concerns tonight. I don't want to see any more blank looks
Oh,
tomorrow when I ask for resources.
he's tough. He's mean.
Let's look at it. Let's really
He's the mean.
start grinding in tomorrow. We don't have that many more days here together left, and we're starting to.
This is
really-
only day 2, y'all. This is only day 2. Thank you, Michael. Eric, thank you so much. We're just.
Thanks a lot, everybody, and good night. That's a long day. Way to go, and good luck tomorrow. Hope it goes well.
Thank you.
Forget the last slide.
No, we did it. You did it. We did that already.
Oh, we did it?
Oh, yeah.
Sorry. Thanks, Eric. Good night.
Thank you. Have a great night. Bye-bye.
Hey.
Hold up.